Hi guys, welcome to the physics class. In this session we are going to discuss about household electrification. If you look at this pictorial representation of a tree system, you can see two lines coming from the electric post reaches first to the watt-hour meter. These two lines are live line or phase line and neutral line. From the watt-hour meter, a third line starts, and this line is earth line. After this watt-hour meter, you can see a main switch. And you know what is the function of the main switch? The electricity reaches the electrical appliances through the main switch. Therefore, instead of turning each switch off, the main switch can be switched off. That is the advantage of main switch. You can see a main fuse placed in between the watt-hour meter and the main switch, and the phase line passes through this main fuse. What is the advantage of this? What is the use of this watt-hour meter? The watt-hour meter is used to measure the electricity used. So three lines are there in this system. They are phase line, neutral line and earth line, and these three lines are wires. Lines or wires are marked using different colors. Phase line is marked in red color, neutral marked black in color, and earth with green color. So let's see how these household devices are connected. All these household devices are connected in parallel. They are connected in parallel. Where is the earth wire connected in a 3-pin socket? In a 3-pin socket, earth wire is connected to the pin E. So we have already discussed that all the household devices are connected in parallel. So what are the advantages of connecting these devices in parallel? By connecting these devices in parallel, the devices work according to their marked power. They can work according to their marked power. And the devices can be controlled using switches as per need. Individual switches can be used to control each devices. The bulbs also will get required voltage. These are the advantages of parallel connection. Now let us see more about watt-hour meter. We have already discussed that watt-hour meter is a device used to measure the electricity used. So it is a device that is used to measure the electrical energy. This electrical energy is measured using the unit kilowatt hour. This is also known as a unit. Then 1 kilowatt hour is known as 1 unit of electrical energy. The commercial unit of electrical energy is kilowatt hour. kWh, kilowatt hour. So what is 1 kilowatt hour? 1 kilowatt hour means if a device of power 1000 watt, that is 1 kilowatt, is used for 1 hour, it consumes 1 unit of electrical energy. So 1 unit of electrical energy or 1 kilowatt hour means a device of power 1000 watt, that is 1 kilowatt, works for 1 hour. Then it consumes 1 unit of electrical energy, that is 1 kilowatt hour. And we can calculate the energy in kilowatt hour using the equation power in watt into time in hour divided by 1000. That is the equation that can be used to calculate the electrical energy used. So let us solve this problem. A grinder of power 750 watt works for 2 hours. Calculate the energy consumed. So in order to find out the energy in kilowatt hour, you have to use the formula power in watt into time in hour by 1000. So here power in watt is 750, time in hour is 2 by 1000. So 750 into 2 by 1000, that is 1500 by 1000, that is 1.5 unit or 1.5 kilowatt hour. The other question, in a house, 5 CF lamps, each of 20 watt, works for 4 hours. 4 fans, each of 60 watt, work for 5 hours, and a TV of 100 watt works for 4 hours in a day. what will be the daily consumption shown by the watt hour meter. So we have to find out the total consumption. So in order to find out this, we have to find out the total consumption of CFL, fan and TV individually. After that we will add all together. So first, 4 hours consumption of 5 CFL having 20 watt can be calculated by 5 into 20 into 4 by 1000, that is 0.4 kilowatt hour. 5 hours consumption of 4 fans having 60 watt, that is 4 into 60 into 5 by 1000 is equal to 1.2 kilowatt hour. Then 4 hours consumption of 1 TV having 100 watt, that is 1 into 100 into 4 divided by 1000 is equal to 0.4 kilowatt hour. So the total unit is equal to 0.4 plus 1.2 plus 0.4 is equal to 2 kilowatt hour. Next, we are going to discuss about the safety measures in household electrification. First one is a safety fuse. You know what are the circumstances that lead to the flow of excess current in a household circuit? That is overloading or short circuiting. What happens when there is an excess current in a circuit? More heat is generated, so the appliances and the circuit will get damaged. So let us discuss how a safety fuse protects a circuit. The current in the circuit may increase due to the reasons such as a short circuit, overloading, excess flow of current, or any other problems such as insulation failure, etc. So as the high temperature produced in the circuit due to these reasons makes the fuse wire to melt and the flow of current stops. So the circuit and the appliances are protected, and we can brought back the circuit to its original state by using a fuse wire of suitable amperage after rectifying the issue of excess current in it. The second one is MCB, ELCB or RCCB. Nowadays we are familiar with MCBs, ELCBs and RCCBs. So what are the differences between an ordinary fuse and an MCB? Ordinary fuse making use of the heating effect of electricity, while MCB works making use of the heating and magnetic effect of electricity. The current in the circuit may increase due to the reasons such as short circuit, overloading or excess flow of current or any other problems in the insulation, as you know. So as the higher temperature produced in the circuit due to these reasons makes the fuse wire to melt and the flow of current stops. That is the case what happens in the fuse wire. But in MCB automatically breaks the circuit whenever there is an excess flow of current due to the short circuit or overloading. It automatically breaks the circuit. So after rectifying the circuit, we can switch on the MCB and make the circuit as it was. So what is the advantage of MCB over a safety fuse? MCB is more sensitive to current than fuse. In case of MCB, the faulty zone of the electric circuit can be easily identified. With MCB, it is very simple to receive to the supply. We can receive to the supply very easily. MCB is reusable and hence has less maintenance and replacement cost. These are the advantages of MCB over a safety fuse. I will repeat once again. MCB is more sensitive to current than fuse. MCB, we can easily identify the faulty zone and it is very simple to resume to the supply. And MCB is reusable and hence it has less maintenance and replacement cost. So other than MCB, you heard the term ELCB and RCCB. Let's see what is the function of ELCB or RCCB in the circuit. ELCB helps to break the circuit automatically whenever there is a current leak due to insulation failure or any other reason. In ELCB, one end of the relay coil is connected to the outer metallic cover and the other end is earth. If current leaks into the earth due to insulation failure or any other reason, a potential difference is developed between the ends of the relay coil. As a result, ELCB gets tripped off if the current exceeds a particular limit. This is with the help of a relay. But in RCCB, There is a provision to distinguish between the phase current and neutral current and to break the circuit if needed. So RCCB ensures more safety than ELCB. The third one is 3-pin plug and earthing. In this figure, which are the lines that are connected to the coil of the electric iron? Phase and neutral. If the phase line comes into contact with the body of the appliances due to the defects in the insulation, what happens to the person who touches the body of this appliance? The person will get electric shock. So how can safety be ensured using a 3-pin plug? This is what we are going to see. The pin E of a 3-pin plug comes into contact with the earth line. Pin E is connected to the earth line. This pin is, so since this pin is connected to the earth line, this pin is connected to the body. We can say the pin is connected to the body of the appliance. If the body comes into contact with an electric connection, the electricity flows to the earth through the earth wire. Since this earth wire is having more thickness, the flow of current to the earth through a circuit of low resistance increases the current. So more current flows through this earth wire because it is having low resistance due to its thickness. Hence, heat generated in the fuse wire increases. So as more current flows through the circuit, more heat will be generated. So the heat generated in the fuse wire increases and the fuse wire melts and the circuit is broken. This will protect the instrument and the person handling it. Since the fuse wire is melted, the circuit is broken. So the instrument and the person handling it will be protected. This is how the 3-pin plug ensure the safety. Let's see how the earth pin differ from other pins. Why is it made different in this way? The length and thickness of the earth pin is more than that of the other two pins. The length and thickness of this earth pin is more than the other two pins. Since the length is more, when the 3-pin is introduced into the socket, the earth pin comes into contact with the circuit first. It comes in contact with the circuit first. Then when the 3-pin is pulled out of the socket, ഇതിനെ നമ്മൾ സോക്കറ്റിൽ നിന്ന് പുറത്തേക്ക് എടുക്കുമ്പോഴും the earth pin will be the last to break the contact. ഈ earth pin ആണ് ഏറ്റവും അവസാനം ഇതിൽ നിന്നും പുറത്തേക്ക് വരുന്നത്. Hence, complete safety is ensured by the 3-pin plug. Complete safety is ensured by this 3-pin plug. Since the thick copper wire is used as the earth wire. ഈ earth pin ൽ നിന്ന് നമ്മൾ കൊടുക്കുന്ന earth wire എപ്പോഴും നല്ല കട്ടിയുള്ള thickness കൂടിയ copper wire ആണ്. So a path of a low resistance is created. So it can carries more current than the amount of current coming from the phase. ഈ ഫേസിൽ നിന്നും വരുന്നതിനേക്കാളും കൂടുതൽ കറണ്ടിനെ ഇതുവഴി ഇതിന് എർത്തിലോട്ട് കൊടുക്കാൻ സാധിക്കും. So this is the advantage of a earth pin. As you know, the electricity we get in our home is AC, but many devices are working on DC. Most of the devices that work only on DC work by converting AC into DC. Mobile charger is a device that converts AC into DC. So let's classify the devices known to us as those working in AC and DC. So examples of devices working in AC are fan, TV, fridge, computer, etc. And those working in DC are mobile, calculator, torch, remote, etc. Rectifier is a device that converts AC into DC. AC is converted into DC after lowering the 230 volt AC to 12 volt or 6 volt. The 230 volt in 12 volt or 6 volt കുറച്ച ശേഷമാണ് ഉപയോഗിക്കുന്നത് as required for the devices. And this is done by using a step down transformer or inductor. The main part of the rectifier is an electronic component named diode. So the main part of a rectifier is a diode. This conducts current only in one direction. This diode will conduct current only in one direction. In addition to such, the rectifiers that make use of different electric components are also in practice. Next, we are going to discuss about electric shock. Of the accidents related to electricity that occur in India, about 10% is taking place in Kerala. Electric shock often leads to death itself. Hence, electricity is to be handled with utmost concern for safety. In addition to electric shock, blisters may also occur. If somebody gets an electric shock, the main switch should be switched off immediately. Then separate the electrocuted person using a dry wooden piece or a dry insulator material. Never touch the affected person using bare hands. Sometimes high voltage shocks may not cause any damage. Even then, one should seek medical help immediately because it may affect the brain. Epilepsy, depression, anxiety, etc. may occur. Even if the voltage is small, it may lead to unconsciousness, damage to touching sensation, decrease in vision and hearing disabilities, etc. The following are the precautions to be taken to avoid electric shock. Never handle electric equipments or operate switches when the hands are wet. Insert plug pins into socket and withdraw them only after switching off. Do not operate devices of high power using ordinary sockets. Wear rubber footwear while operating electric devices. Do not touch the interior part of the cable TV adapters. Ensure that there is an insulated cap for the adapter. Do not fly kites near electric lines. Do not use table fan to dry hair. Ensure that there are no tall buildings or tall trees near electric lines. Ensure that the main switch and ELCB are switched off when maintenance work is being carried out at home. Some of the precautions we have to take on during some special circumstances. First one, during lightning, avoid doing any work that will bring you in contact with electric circuits. There is a possibility of excess current in the circuit during lightning. Then disconnect the plugs from the socket whenever there is a chance of lightning. During rain and winter, electric lines are likely to touch the ground. This may cause danger. We have to be cautious on such occasions. If water enters home due to flood or other reasons, disconnect electric connections. Reconnect it only after ensuring that the main switch and the switchboard are perfectly dry. First aid should be given only after disconnecting the victim from the electric wire in case of electric shock. As a result of electric shock, the body temperature of the victim decreases. Viscosity of the blood increases and clotting of blood occurs. In addition, muscles of the body contract. How to provide the first aid? Raise the temperature of the body by massaging. Give artificial respiration. Massage the muscles and bring them to the original condition. Start first aid for the functioning of the heart. That means apply pressure on the chest regularly. Take the person to the nearest hospital immediately. These are the first aids to be provided when a person is affected with electric shock. Electricity is an integral part of our day-to-day life. This energy is to be conserved for tomorrow. Hence, its consumption should be reduced to the minimum possible. Remember, saving electricity is equivalent to generating electricity.